Welcome everyone to our IAQM webinar, The Effect of Euro 6 Vehicle Defeat Devices on Urban Air Quality. Today we are joined by Dr. Mark Peckham, who is a Director at Combustion. After graduating from Edinburgh and Cambridge Universities, Mark spent some time working at Ricardo Consulting Engineers before joining Combustion in 1994. Mark now looks after the Fast Response Gas Analyzer Department. In today's webinar, we'll introduce the findings of recent tests done to explore the impact of defeat devices fitted to diesel vehicles on air pollutant emissions. As always, there'll be a chance to ask questions at the end of the presentation, so please do pop these in the Q&A option at the bottom of your screen at any point during the presentation, and I will ask these on your behalf at the end of the presentation. Thank you for logging in today, and I'll now hand over to Mark.
Well, good afternoon. Thank you very much. And I hope you can all see my screen quite effectively there. So clean air zones, low emission zones are universally loved and respected throughout the land. Nothing politically contentious, even in Uxbridge. But ultimately, they do rely on automatic number plate recognition systems to determine whether one's vehicle can gain access to these areas. And by inputting the registration number, you can get a determination of the emissions Euro classification of the vehicle. And generally, there's a cutoff between Euro 5 and Euro 6 emissions vehicles. Euro 6 generally are allowed access to low emission or ultra low emission and clean air zones. But it's all basically down to the number plate, because the number plate is the key to linking to the emissions classification of the vehicle. And that's for good reason as well, because if we look at these three maps, these are of the TfL West London route, where we've driven round this route in three different vehicles of three different emissions classifications. The one on the left is a Euro 5 diesel, that's from 2011. The one in the middle is a plug-in hybrid electric vehicle, and that was from 2017. And the one on the right is one of the latest classes of diesel vehicles, a Euro 6D vehicle. And Euro 6D was really a bit of a game changer. There was a huge step up in terms of the emissions effectiveness for Euro 6D. So what I'm showing you here is a route which starts at the top of the triangle at Brent Cross Shopping Centre. We go down Finchley Road, we basically go around this triangle clockwise, down Finchley Road, through Piccadilly Circus, along Kensington, back up through Acton and Ealing and Neasden. And then we join the M1 motorway back at Brent Cross, where there's quite a hard acceleration on an up ramp to join the M1 at high speed. And then we go up the motorway to the first service station, turn around, come back down again, and we're back at Brent Cross. And that's the cycle. And it's 55 kilometers of very, very boring driving. But while we did this route, we were sampling the NOx from the tailpipe of the vehicle. And we had GPS on board. So what we've plotted here are the positions of the concentrations of NOx from the tailpipe. And you can see the Euro 5 diesel on the left. It's basically peppered all over the place. Euro 5 diesel doesn't really have any catalyst system to take out NOx. It relies purely on a method called exhaust gas recirculation, which can be effective, but back in 2011 it was quite customary for that to be switched off during cold weather to stop clogging of the EGR valve. It just so happened that the day we did this test on wasn't terribly cold. It was about 19 degrees, but you can see how there's a very persistent and frequent emission of NOx from that vehicle. The middle vehicle, which is a plug-in hybrid, very popular brand hybrid vehicle, and which is a petrol, you notice that its emissions, its NOx emissions, are concentrated in just three areas. So there's this one where I hope you can see my mouse pointer, but this is the Finchley Road, the Swiss Cottage Gyratory, where there's a lot of acceleration, deceleration, braking. And when this engine, being a hybrid, the engine is stopping and starting a lot, if it starts under high load, so starts under a hard acceleration, then you tend to get a little spike of NOx coming out of the tailpipe. So this happened at that gyratory and also at two sections of the road where there are speed bumps. So with a speed bump, you decelerate towards the speed bump, the engine switches off, you go over the speed bump, and then you accelerate away from the speed bump, you start the engine again under high load. So this produces these pockets of NOx, but very much reduced from Euro 5 diesel. And on the right-hand side, you can see that even the speed bumps and the Swiss Cottage gyratory, they've all been largely solved. Still a little bit of NOx coming up on that hard acceleration up the M1 round, M1 on-ramp. So I'm now going to show you a little video of the Euro 5 diesel getting onto that on-ramp and what it does. So what you'll be able to see here is a rolling graph. I'm going to start this rolling. The black is total NOx. The blue is just the nitric oxide portion. And the red is the cumulative NOx in grams. So this is the concentration multiplied by the exhaust mass flow rate. And this shows how many grams of NOx are being kicked out of the tailpipe. And that's quite alarmingly large. But with every gear change, you can see there's a drop in NOx, because as your foot comes off the accelerator, there's no load on the engine, there's no combustion, you get no NOx. But look at the rate at which that red line is rising. So we're knocking out about a gram of NOx every 8 seconds during this hard acceleration as we try to join the motorway at an appropriate speed. So that's the bad old days. Things aren't like that anymore. And if we look at that same data, but this time we're looking at the cumulative mass, okay? So we're effectively looking at what was plotted in that red data in the previous movie. But you'll see that with Euro 5 diesel in blue, you can see that it's just knocking out NOx all the time. You know, there's just a steady stream of NOx. And in some situations where there's a very sharp increase, that's like the M1 on-ramp. But very large amounts of NOx being produced. When you go to Euro 6B, the plug-in hybrid, you can see that the NOx is very much reduced. So there's been a huge improvement in NOx. So basically the blue car, the Euro 5 diesel, wouldn't be allowed in most clean air zones, ultra low emission zones. The red one would be, and its NOx is so much lower. But if you take a look at the purple trace right down the bottom here, this is a modern Euro 6D diesel. And a lot of care has been taken into reducing the NOx from that diesel engine using this technology, SCR, selective catalytic reduction. And this is the most common, I think it's fair to say, the most common type of technology for reducing NOx in modern diesel engines, both car engines and vans, but also on trucks as well. So here is that Euro 6D vehicle that we tested. We actually bought this new in 2018 when Euro 6D first came out, and we put it on our rolling road here, and we ran through many drive cycles, and we monitored lots and lots of aspects of how this vehicle performed in terms of its emissions, but also how it evolved. So modern calibrations for modern diesel engines, Euro 6D diesel engines, contain an aging function, such that when they've done 10,000 miles, for example, they slightly change their catalyst heating strategy. And we could see this extending. We can see this switching several times. As the catalyst gets older and it's not quite as effective as it was when it was absolutely brand spanking new, they elongate the catalyst warm-up period by changing by modifying the calibration of the engine with respect to the number of miles it's done. So it's a beautiful piece of calibration. It makes the hair stand up on the back of you. But this vehicle, one of the first Euro 6Ds which were available, they're now, what are they, 6 years old? Many of them done maybe 100,000 miles, and they're starting to get a little bit long in the tooth. And they're subject to MOTs now, where if there's a fault light on, if there's a fault light showing, you have to get it repaired. Otherwise, that's an MOT fail. But also Euro 6D has got within it a certain level of immobilization. So if the SCR system fails or has a fault, the first thing that happens is a light comes on and you have a warning saying you must get this fixed within the next 500 miles. And if you don't do anything after the next 100 or 200 miles, the engine is then derated. So some power is taken away from you. The engine is not allowed to develop its full power. And if you don't do anything when the 500 miles is up, the engine simply won't start. So this was one of the mandates of Euro 6D to try and make it as tough as possible. You can't ignore the fact that you've got a light on. But this has kind of stimulated a growth in tamper devices or defeat devices. And if you want to get your SCR fixed properly, this can cost you pushing £1,000, maybe £800 to get an SCR fixed properly. Or you can pay £40 and plug in an Adblu emulator. And the Adblu emulator fools the engine management system into thinking that the SCR system is working fine, switches off all the lights. So when you present it for an MOT, the tester can't see that there are any faults. And although it's knocking out a fair amount of NOx, the current measurement systems for NOx aren't really sensitive enough to spot, and the conditions at which the NOx is tested, just at idle, are not really sensitive enough to spot that an emulator or a defeat device has been attached. Now, there are a number of companies out there who will, they may sell you a device to plug in, but they will also offer to remap your vehicle. They will claim multiple things. They may claim fuel economy improvements, because that catalyst heating function I talked about before, they could delete that because there's no need to pre-warm the catalyst anymore because the catalyst isn't doing anything. So they can claim fuel economy benefits. You don't need to buy Adblu anymore. And often they will offer this service also taking away the diesel particulate filter. So not only are you turning the vehicle into a rather high NOx emitter, but you're also often making it into a high particle emitter as well. Sometimes they also claim that they're boosting the power of your engine. So they'll try and entice you in with all these benefits, and not forgetting the fact that you're paying less than you would be if you were getting the SCR system fixed properly. Now, if you indulge me just for 2 minutes, I'll go through how an SCR system works, because it is fairly pertinent to the oncoming discussion. So on the left-hand side, we have an engine, and it is producing, because of combustion, it is producing some NOx, mostly nitric oxide and nitrogen dioxide, but some N2O in there as well, some carbon monoxide, some unburned hydrocarbons, that's unburned fuel basically, and some particulate matter. Now, we'll not consider the particulate matter today, but the next block in line is fairly important. This is the oxidation catalyst. And with a modern SCR system, the oxidation catalyst is there to promote the conversion of NO to NO2. NO2 being much more susceptible to being reduced by the SCR reaction. So that oxidation catalyst, when it's hot, it oxidizes the NO to NO2 in the hope that the NO2 will be reduced very effectively by the SCR system. It also takes out any unburned hydrocarbons and any carbon monoxide because it oxidizes those. Then the gas passes through a spray of urea liquid, that's the trade name for that is Adblu. That decomposes to ammonia, NH3, reacts on a hot catalytic surface with the NO2, and the outputs from that should be, as seen on the right-hand side, should be benign products like nitrogen and water. CO is oxidized to CO2. Particulate matter is normally caught with a DPF. So all this happens, and a NOx sensor, a fairly cheap screw-in NOx sensor, is sitting at the tailpipe and monitoring the amount of NOx which is being emitted from the whole system. And if it goes high because there's a fault, that leads to a light coming on the dashboard and a potential MOT failure or a potential derating of the power of the engine or immobilization. The last little thing in the chain, the last block in the chain is this ammonia slip catalyst. So any ammonia, if it's overdosed with ammonia by accident or during a lot of very transient driving, this last oxidation catalyst cleans that up. But remember that this whole system only works properly if it's maintained at high temperature. So generally the cutoff temperature is about 200 degrees C, maybe 180 degrees C. But diesel engines are really very efficient. They can take a lot of the heat out of the gas. So their exhausts tend to be about 200 degrees colder than the equivalent sized petrol engine. So if you're driving in the centre of London or in an urban area where you're not actually giving it a lot of welly, you're not accelerating very hard, you're just tootling around in congested traffic, the engine management system actually squirts some fuel in during the exhaust stroke. They therefore deliberately put in hydrocarbons into the exhaust. They land on the oxidation catalyst, and when they exotherm in here and effectively maintain and heat up the urea, the SCR system. So it's this that the remappers claim to be saving, because their remap stops this exhaust injection purely for thermal maintenance of the SCR system. Right. So the more you pay for an SCR system, the lower that temperature can be. Older SCR systems, they had to operate at 240 degrees for them to work efficiently. Modern ones can be down at 160 degrees. But that's why it's very important for the thing to remain hot. But if you apply a defeat device, what happens is your SCR system will no longer squirt in any of the Adblu urea. It will ignore the NOx sensor, normally by putting a false 2 or 5 volt signal where the NOx sensor signal should be sitting. So it fools the engine management system into thinking that everything is okay. The one thing it doesn't do, though, is it can't change the oxidation catalyst, because this is just a ceramic brick coated in precious metal, which is part of the exhaust system. So your engine is still producing NO and NO2. The oxidation catalyst is still converting the NO to NO2, but your SCR system has been disabled. So potentially you could be knocking out a much higher proportion of very toxic NO2. Right. If you Google for Adblu emulators or SCR emulators, you will find an alarmingly high number of them available. That top one there just so happens to be from Bedford, that hotbed of criminal activity, but you can find them all over the place. And you will, if you look at their websites, you'll often find those claims that I listed before. You will sometimes find a disclaimer hidden in the small print, which starts off by advocating the remapping, but also sometimes mentions that if you get this done, you're not supposed to use this vehicle on the road within the EU, because the system has been disabled, and that could result in prosecution. I have to say that when I looked for this example of a disclaimer, I had to look pretty hard. I looked about past 15 or 20 websites to try and find one that applied this disclaimer. But you know, it is and should be realized and appreciated. Now, this, therefore, you remap your engine, you take away your SCR system, it basically turns a Euro 6 vehicle into a gross emitter. And we've done a fair amount of work in identifying individual gross emitters using an ANPR camera and a fast NO and NO2 analyzer. And here's a typical setup that we deployed in South Wales last year, where we have the NOx analyzer sitting in this waterproof case. We have a pipe sitting on the curbside, and we have a camera which is clocking the number plates of the vehicle coming towards our measurement system. So the view from the camera looks like this, and our sample point is just off to the right-hand side, just after the pedestrian crossing. So if I roll this video, you'll see the real-time NO and NO2, and you'll see any spikes associated with passing vehicles. So this white van that's going past, as its exhaust passes to the right of the camera, you'll see virtually no increase in NO. But when you look at this chap with the ladders on the top, as they drive past, you get a lovely spike there. And there's no question that that spike isn't associated with that vehicle. So then you go to whatever is your favorite website where you can look up the vehicle details. There's no personal details on here, but the vehicle details show that in this column to the right-hand side here, you can see that for that number plate, that's a Euro 6D vehicle. So that really should be very clean for NOx. Now, maybe you could give him the benefit of the doubt and think, well, he just lives around the corner. He's only just started his engine. The catalyst is still cold. The catalyst heating system hasn't had time to warm up yet. But for whatever reason, that was one of the highest emitting vehicles we saw passing that day. And yet it is a Euro 6D. We saw some others which were Euro 4s, which you might expect to have high NOx because they don't have any catalyst systems on. We've also done a little bit of work where we've done some pursuit work alongside the DVSA, where we've put our analyzer in the boot of their pursuit vehicle, and we've extended the sample pipe to be protruding from the front radiator grille. So we're basically sniffing the wake or the exhaust plume of the vehicles in front. And these exercises were largely interested in commercial vehicles, so trucks and vans. And what would happen is we would identify an unusually high tail plume of NOx, and then the driver of this stopping vehicle would get in front of them, pull them over into an inspection site where a group of kind of 10 inspectors would crawl all over the vehicle, and effectively they would look for defeat devices. They'd even look in the software, the engine management software, and see if there is anything untoward in there. And for all the vehicles we pulled over, I think the stat turned out to be about 92% that we indicated indeed did have some evidence of tampering. Now, I can't show you any of that data, but here is a little bit of data of a perfectly legal bus in the middle of Cambridge, where we're sampling in the same way, but with one of our own cars. And if you just watch the NO and NO2, you'll see as we pull away, we're sniffing the exhaust plume of that bus in front. The bus has been in a very congested city centre, and its exhaust is quite cold, but you can see the amount of NO and NO2 that's being produced at some distance. And also, it tends to produce it more as it's pulling away from traffic lights. So it's under load, it's been sitting at idle for a long time, and the exhaust has cooled down. So that's just a couple of techniques that we can use to identify gross emissions. Now, what we did was we took the Combustion Works van, which we deliberately bought as the equivalent vehicle to the Euro 6D car that we tested within an inch of its life, which I presented earlier. This has exactly the same 1.5 litre Euro 6D diesel engine in it. We took this vehicle, and the intention was to run it on our rolling road with a robot driver and run a series of repeatable drive cycles. Then we take it to a remapping center and then retest the same drive cycles after its SCR system had been defeated and look at how much worse the pollutants were. However, there was a hitch in that plan, because although we are beautifully furnished with several rolling roads and several robot drivers, they're all absolutely stuffed full of work at the moment, and I couldn't get a chink in any of the testing services to get our van on there. However, most of the remapping services also have a they have a rather simple rolling road. You can't run transient drive cycles on it, so we can't do a European drive cycle or a WLTC cycle. But what we can do is hold the engine, hold the vehicle steady at 20 miles an hour, 30 miles an hour, 70 miles an hour, and apply a load to the engine, which would be similar to driving on the motorway or driving on through a town, but only at steady state points. So that was as good as we could get. So what we did was we took our gas analyzers, the fast gas analyzers in the boot of that van, to the remapping center, which are all fairly kind of ropey looking places. They're all a bit of a mess, but effectively they've got computers and hardware there to start tampering with your vehicle. We took some baseline readings at idle, 20 miles an hour, 30 miles an hour, 50 miles an hour, and 70 miles an hour. And we measured the NO and the NO2 at all of those different settings. We then got what's his name to do his stuff. We asked him not to take out the DPF, just to switch off the SCR system as simply as possible. But even just doing that, he was very keen to give us a certificate of remapping. I'm not sure why you'd want to ever present the certificate to somebody, because it's basically showing that you've done something illegal to your car. But what he was trying to prove here was that we've boosted its power from 101 brake horsepower to 140, and its torque had increased from 250 to 314 Newton meters. So you see how I've reducted this to spare his blushes. So finally, let's have a look at the data. This is the data in ppm, parts per million, of the tailpipe NO and NO2 before any tampering took place, so before any defeat devices were fitted. So you'll see that these ppms are really very low, certainly single digit and often zero. And then if we did exactly the same tests at exactly the same speed load points after defeating in red, you'll see that they are now absolutely horrendous. And I was going to work out the percentage increases, but because some of these starting points before tampering were zero, that's a divide by zero, so you can't really do a percentage increase. But they are horrendous. I mean, they're hundreds of times higher. So we've increased the NOx from this vehicle, of it being a beautiful Euro 6D low NOx emitting vehicle, to, if we go back to that graph I showed you from the London tests, we've taken that purple line and we've leapfrogged way over the red and the blue, and we're now up to the ceiling of this office. So this vehicle can still gain access to low emission clean air zones because its number plate is still stating that it's a Euro 6 vehicle, but it is an absolutely horrendous high emitting vehicle. Okay, so on that bombshell, I'll happy to answer any questions.
Yeah, if anyone does have any questions, please pop them in the Q&A box. I just wanted to ask, with regards to MOTs, do they pick up vehicles that have been remapped? Like if someone's conducting an MOT on a car, would they know that that car has been remapped?
If it's done really badly, if the DPF system has been cut out and just a bit of pipe has been put on, they can spot that, but that's a visual spot. That's not because the sensors have picked anything up. Certainly not in terms of NOx and particles. But what is being revised at the moment is the MOT test. So the discussions are taking place to try and tighten up on this sort of thing so that more could be spotted. But at the moment, it's a rather weak, flimsy test, and it's not really fit for purpose for looking at Euro 6D vehicles which have been defeated.
Perfect. There is a few questions, so I'll just start with them. Next asking, is SCR and Adblu the only way diesel engines achieve Euro 6?
No, there is also something called lean NOx trap, where the diesel engines always run with excess air in their exhaust, which means they always run what you call lean. But there is something called a storage catalyst, which traps all the NOx, and then every 20 minutes or so, the engine runs rich. It squirts during the exhaust stroke and adds hydrocarbons into that NOx trap. And the hydrocarbons and the trapped NOx react with each other and give a clean output. So that is an alternative way of denoxing. There used to be something called a continuously regenerative particle trap as well, which trapped soot on a DPF and then accepted NO2 to react with the soot. I think that's largely fallen by the wayside because you have to balance those two quantities very carefully. If you get them wrong, then you start to emit a load of particles, or you start to clog up your DPF with particles. If you get too much NO2, then you get no particles, but all the NO2 starts to tip out the back of the car. So that was always a more tricky technology. But short answer is yes, there are other ways, and those are the two other main ways of tackling NOx.
Perfect. Someone's saying here, really interesting, thank you. I bought a second-hand diesel car that was Euro 6D category. How would I know if it had been tampered with if it still passed the MOT?
Oh dear, you won't. Well, you could take it to the dealer, or an auto tuning place, ask them to plug into the diagnostic port. There's a little port which looks like one of the old video SCART cables. They'll know where to find it. And they can look at it and see if there's anything odd going on, because sometimes there are telltale signs when you look through the onboard diagnostics port. That was one of the things that the DVSA were doing. They were looking on the port and seeing if there were, normally on these ports you get a number of errors which are quite low-level errors. They're not presented to the driver in any way, but a list of errors pops up if something's a little bit cold or a signal has dropped out for a few seconds. It doesn't stop the engine, doesn't alert anybody. There's normally a list of a few errors. What you can look for are absolutely no errors, which is so clean you can smell a rat. And that's normally because that section of the map has been wiped or is not being written to anymore by the firmware. But basically, it's difficult to tell. You wouldn't be able to. You could bring it to combustion. We'd charge you a happy sum for measuring the NOx, but you would get through an MOT probably without any trouble. And that's the kind of scandal. And this problem is increasing apparently exponentially because of the aging fleet of Euro 6D vehicles.
Perfect. And there is a few questions to that effect. Kind of. Do you have any estimates of the rates of defeated devices? Someone's asking the percentage of defeat devices on the road, and another question, how common these are. But just from what you've said, I guess it's something that's becoming more and more widespread.
It is, but I'm only going on anecdotal chats with the Vehicle Certification Authority and the DVSA, who, yeah, it's a thing of concern. It's a thing of concern. It appears to be growing, and when you go looking for a defeat device, you'll find that the websites will give you a kind of menu to choose from, depending on what vehicle you have, because they're all controlled in slightly different ways, but they can really quickly, on the dark web, they can really quickly find out how to defeat a new vehicle's SCR system. Really unscrupulous fleet owners, say if you're an unscrupulous courier company and you've got 50 diesel vans, or a taxi company, for example, and you fancy saving a little bit of fuel, there's a temptation there, shall we say.
Okay. Can it be undone? Like if a car has been remapped, can it be undone?
Well, oh, now you get me started. It sort of can,
Okay.
but if can you still see my screen at all?
Yes.
So if, for example, I went back to the SCR schematic, like that one, you see this urea dosing system. There's a nozzle in here which squirts and atomizes the Adblu into the exhaust system. If you switch off the Adblu, but the DPF system, the particulate filter system, is still regenerating, because a regenerated DPF requires the exhaust to have high temperature, elevated temperatures. You can find that the high temperatures burn and damage the tip of the urea dosing system. It is normally cooled by the flow of Adblu, but if there's no cooling flow, but the exhaust still gets hot, you char and burn and damage the nozzle, and that breaks it basically. So it's difficult to go back, or I should say it's expensive to go back. You're basically back to fitting new nozzles, and that's the kind of expensive bit, why you turned away from doing it properly in the first place.
Great. There's a question here about do you know if there was any action taken against the drivers that were pulled over by the DVSA officers? And I guess if you buy a car that's been remapped, are you liable for that as well?
I don't know the answer to question 2,
Okay,
but question 1, yes, action was taken.
okay.
Yeah.
Perfect. There's a few questions, so I'm just going to go through these. Hi, Mark. I would be interested to hear if you have considered your results in the context of COPERT emissions calculations if a high enough proportion of the UK fleet is tampered with.
That's right. That's right. So this does have knock-on effects to the assumptions that are made for air quality. But what I'd really like to do is to do the testing properly with some proper drive cycles, because this was all a bit, you know, just those fixed speed load points, the bit kind of, you know, B standard. I really need to get onto the chassis dyno. We've still got the vehicle here. We can still get it redefeated and then hopefully put back to normal again. But I want to do this properly. And then, of course, this is just what one vehicle does. A truck might do something of a different magnitude. A different type of diesel vehicle may well react in a different way. This is just one vehicle defeated in this way, but the results are horrendous. So worth noting. The one thing I thought might be worse, though, is the proportion of NO2. I thought that because of the oxidation catalyst and what I mentioned before about the oxidation catalyst changing NO to NO2 and being unaffected by the remapping, I thought we might see a much higher proportion of NO2. That wasn't as bad as I thought it was going to be. So there you go.
These two questions are kind of related. Is this an issue that only happens with Euro 6D vehicles? And someone's asked, have you looked at tampered Euro 5 engines? Does this result in a similar emissions to those seen on tampered Euro 6?
I haven't looked at tampered Euro 5 because they tend not to be fitted with, well, they tend not to be fitted with SCR systems anyway. SCR systems are quite expensive to fit. So manufacturers really only started to fit them when the NOx legislation level was so low that they couldn't get away without fitting them, or they had to do a lean NOx trap or a, you know. So the customer pays more for Euro 6D vehicles because all this candelabra is hanging off the back. No, so we haven't looked at how defeat devices might affect Euro 5. I know that there is a known defeat which is to remove the EGR valve or to crack it permanently open so that it doesn't block. You often see Euro 5 vehicles which are producing huge amounts of soot, and that's probably because they've had both their DPF removed and their EGR valve bypassed or removed. But they're on the road and you follow them and you have to shut your ventilators because you can smell them. They're horrendous. And you can see them as well. You know, you're following a cloud and it's coming in your cabin air. Awful.
We've got time for just two more. So Natalia is saying, I find it interesting that you have chosen a plug-in hybrid as a comparison in the first study you mentioned. Why was this chosen over a self-charging hybrid which shares the same WLTP test process as ICE?
So we had that plug-in hybrid because it was given to us. We didn't have access to anything more. I mean, it was a petrol as well, so it is a little bit odd. But it was interesting the way it reacted. Plug-in hybrid has a relatively large battery on board. So when you accelerate away from standing start and the engine restarts, it probably exacerbates that spike of NOx somewhat. But the catalyst system is it was a new vehicle. I mean, I think we got it with 7 miles on the clock. But even from new, it only legally, 6B as well, only needed to legally meet the European drive cycle, the rather basic geometric drive cycle. I think I'm right in saying it didn't need to meet the emissions legislation from the more transient WLTC, because it wouldn't have fared very well on a very transient cycle. Although how it did fail could easily be calibrated out. And modern, that the equivalent vehicle Euro 6D now is brilliant.
Elizabeth says, what advice would you give to a local authority with a CAS where it is suspected defeat might be impacting on the effectiveness of the CAS? Do you think the DVSA would be open to targeted enforcement campaign in a CAS? Would it be feasible for local authorities to identify high emitters themselves and pursue actions against them?
So what we have done with local authorities is that little exercise where we've sat on the side of a road, normally next to a monitoring station, which for some unknown reason seems to be bucking the trend, and there's a particularly large exceedance of NOx there. And we've seen if we can characterize or categorize what type of vehicle is the biggest contributor to those high NOx levels. We've done this in multiple places. Sometimes the results are a little bit embarrassing because sometimes it's your own buses, or you know, we did a bit of work outside Great Ormond Street Hospital where the biggest polluters were the ambulances, which were idling outside. So sometimes the truth can be a little bit embarrassing. But you can also, we've also done a lot of work where we're identifying the number plates of particular high emitters, but we don't have any power to do anything about it. You know, you found the vehicle, but you've really got to get involved with the DVSA to do anything about it. I know the DVSA have worked with us and a local authority when we've been doing the truck work. That was all done under the auspices of a local authority, so they are open to do that work. Yes.
Perfect. Thank you so much. We've had a lot of comments just to say how interesting and how much people enjoyed it. So that's it from us today, attendees. Thank you for logging in. I hope you found it beneficial and informative.